Network Dojo.
Hey, Jeff Rensink here with Network Dojo, and in this video we're going to talk about sort of a home lab or maybe a work lab setup for SD-Access. Kind of talking about the hardware that I recommend as well as the software that you're going to need for that. So we'll start off on the server side of things. So there's a couple of servers that are required for SD-Access. Number one being DNA Center. Now, if this is just a lab, usually you can just get by with one unless you really want to lab up the clustering aspect of things. And if so, the standard cluster size for DNA Center is going to be 3. So that's definitely going to increase your costs quite a bit, as we'll see here. So unless that's really important to you, maybe that's more for a work lab, but at least for a personal lab, maybe you're doing some CCIE studies or something like that, 1 is perfectly fine. You're also going to need an ICE server because DNA Center and ICE really work hand in hand for a lot of what it does. So ICE is another thing that you're going to need. Just one of those should be fine. Again, unless you want to really get into some more complex ICE stuff, but that's kind of outside the scope of what you need to necessarily worry about for SD-Access for the most part. The other thing that you might want to be thinking about would be an internal DNS server. I don't know that it's necessarily 100% required, but it's not a bad idea. You will need access to an external DNS server. Obviously, you don't have to set that up yourself and run it. But at least on the inside, if you have some internal DNS names and that type of stuff that needs some resolving, not a bad idea to have. And it's just a decent part of a home lab anyways. On the licensing side of thing, we get by pretty easy in general as compared to what you would be doing in production at least. So the nice thing with DNA Center is DNA Center itself has no licenses. All the licenses that have to do with managing devices in DNA Center are all on the devices. So we never install any licenses really on DNA Center. The nice thing is, at least from my experience, I've never needed to install any paid licenses on a switch or a wireless LAN controller if you're going to be doing wireless stuff. So just flipping the switches, saying that it's going to be using the advanced licenses is fine. Eventually, it does get the sort of temporary licenses and they will expire, but even after those temporary licenses expire, they continue to work for me. Even, wiping them, reconfiguring them, all that type of stuff. I haven't ever had to install one of those subscription licenses on a switch. And same thing with controllers. I've never needed to install a license, be it an AP-based license or any other licenses on a controller. So we get off easy in that regard. Now, ICE is a little bit different beast. So I should start with a temporary license that will count down. I think you can use that, although I've never personally used it because I do have licenses on my personal ICE servers for my labs. So you either can just try to work with those temp licenses, and unfortunately, once those expire out, you're going to have to rebuild your ICE server, which is not the end of the world. It's not too much work to rebuild an ICE server in general. Otherwise, if you have licenses available, awesome. The thing is with ICE, you're going to need a few different licenses. One, you need a VM license, assuming it's going to be a virtual ICE server, which is probably what we're expecting here. You need base licenses. You're going to need 100 base licenses because that's the least number that you can buy. And then you're going to need the advanced subscription license as well on top of that. So there's kind of 3 different licenses you need to buy to get ICE working at the level you would need it for SD-Access. So temp license might be the best go-to option there, and just deal with the fact that you have to rebuild the server. And then finally, ESXi. And here we're going to need a license as well. And the main reason for that is DNA Center is going to need a bunch of CPUs thrown at it. And while we can get a free ESXi license, that license is limited to 8 CPUs assigned to any individual VM within the box. So even though we can support many, many CPUs on the box as a whole, virtual CPUs and cores and all that type of stuff, the individual VMs can't go crazy with that. So either you can use the 90-day temp license on ESXi, and then you would have to rebuild ESXi every 90 days, which would probably mean also rebuilding all the VMs on ESXi every 90 days, potentially. I don't know, maybe you can not have to lose your hard drive. Maybe you have a separate hard drive with all the VM stuff that you can just sort of re-add the VMs once ESXi is built. You can play around with that. Otherwise, you're going to need a paid license on that, and we'll talk about the cheap option for the paid license on ESXi. Okay, getting into hardware. So we'll focus first on the ESXi server hardware. So the nice thing here is that we don't have to buy a physical DNA Center appliance. Absolutely, you can run DNA Center virtually in ESXi. I have a separate video about that one, so you'll be able to watch that to see what the process is in terms of setting up that up. But just some real quick high-level information in terms of the specs that you're going to want to look for. First, go used. You're going to save yourself a lot of money going with used servers. A used Cisco UCS server will be awesome. You should also be able to use a used Dell or HP server as well. And you know, the hardware itself shouldn't be super critical because we're virtualizing, right? Everything's sort of abstracted when we use ESXi. So I don't think it's going to really necessarily matter the particular vendor that you get there. It's just, you know, we have options. You'll want not a junk CPU. You don't have to go crazy with that. So sort of a bargain CPU that I use in my racks. I have a pair of Intel Xeon E5 2690 V3s. Those are 12-core processors running at 2.6 gigahertz. So that gives me what, a pair of those, 24, multiply it by 2 for virtual. So I get 48 cores usable inside of ESXi, which is more than enough. Doesn't have any problems handling not only a DNA Center plus a whole bunch of other VMs running on the same box. DNA Center is not super CPU intensive, at least as far as the lab environment goes. So it's not like, again, you don't have to go crazy on the CPU side, but definitely you want to be able to throw a lot of cores at the box. For DNA Center by itself, you'll want 256 gig of RAM. It will use the vast majority of that RAM all by itself. If you want to run additional VMs on top of DNA Center within the same ESXi box, you might want to start looking at some more RAM being thrown on it. So most of my servers, I have 384 gig of RAM, and that allows me to run DNA Center plus like another 6 or 7 other VMs, like a couple of ice boxes, some Prime, and a few other things on top of that. You'll want at least 1 terabyte of solid state hard drive space available. So whatever RAID you're going to use, just make sure that from an available, usable standpoint, you have at least a terabyte. My DNA Center is using, the better part of 700 some gig, and I don't go crazy in terms of lots and lots and lots of snapshots. I have a few snapshots going, and this is all thin provisioned as well. So I'm trying to save as much space as I can. And then if you want more VMs on top of that, you want more space. So a terabyte should give you a little bit of breathing room for DNA Center itself, but if you're going to have a bunch more VMs on top of that, increase the space accordingly. A single NIC is fine for DNA Center, at least, unless you want to get, again, into more replicating real appliances. So if you want to sort of replicate like, hey, this is the real thing, get 4 NICs on your ESXi server. And then again, either that 90-day temp license or a paid license, so that we can get 40 plus CPU, because the normal appliance, I think the smallest appliance that available for DNA Center has 44 CPU, if I'm not mistaken, and then they go up from there. So I try to give it 44 or more CPU. Usually I just throw every CPU that the box has on it. Okay, getting into our wired stuff. So if you want to do wired SD-Access, first, again, continue to look for used equipment. eBay is a great place to find used Cisco gear. You can hopefully find some deals, save you a bunch of money over buying stuff new. So we kind of have a few different components for wired access. We have control plane nodes, border nodes, and edge nodes, as well as fusion routers. Those are kind of the main things that we're typically labbing up. So for that control plane and or border node, our cheapest option is going to be a 3850 series switch. I would recommend probably a pair of these, and that's going to give you some flexibility. So every location in SD-Access is going to need its own control plane and border node, at least one of each. So having 2 3850s allows you to do 2 locations if you want, or within a single location, you could get some redundancy or do some different border node designs if you have more than one of these types of devices. So a pair is going to give you flexibility to practice definitely more than a single one will do. Now, if you plan on getting into wireless SD-Access, as far as the switch side of things go, you might want to consider at least one 9300 switch in lieu of a 3850 switch. mainly because that's going to give you the ability to run an embedded wireless controller. On the 9300, the 3850 does not give you that. So if you have no interest in wireless, 3850s all the way should be great. If you have interest in wireless, you're going to be considering a 9300. On the edge node side of things, the cheapest option is going to be a 3650 series switch, and it's honestly better than a 9200 series switch. For those of us studying for CCIEs, you might see that, oh, my blueprint uses 9200 switches. But 3650s should be able to do everything a 9200 can do, plus it supports a lot more VRFs than a 9200 does. So every time we create virtual networks, that translates into a VRF. There's going to be limitations on the 9200. It's something like 4 VRFs or something like that. So 3650s will scale up to bigger types of designs. And again, maybe a pair of these so that you can have clients spread across more than one node. So you can see clients, moving from one edge node to another edge node. And then finally, a fusion router. This is just going to be any device that supports multi-protocol BGP with VRF leaking. So any device that supports that, awesome. If you want a cheap physical device, a 2900 series router absolutely fits that bill. It can be found for incredibly cheap and do everything that you need with that. If you're already doing other virtual routers, so maybe you're a route switch guy, and you're already setting up, ESXi or some other virtualization platform with a lot of virtual routers, sure, if you got your virtual router that can do this too, cool. Just spin up another virtual router, and that can be your fusion router for this as well. Now, if you're going to get into wireless, we're going to add on to what we've already seen. These are not in isolation. These are on top of what we already saw on the wired side of things. So my recommendation would be probably the 9800 cloud-based platform. You can run that for free. There's no licenses needed on the controllers to install. In production, you would need some AP-based licenses, but lab, you really don't need to. I've never installed one. Runs just fine. One thing to remember, though, if you're running a 9800 CL, the ESXi platform, whether it's going to be the same one that DNA Center is running on or a different platform, whatever you want to do, but just make sure that you have one dedicated NIC on that ESXi server for every 9800-CL that you're running. That's going to be its basically client port where all the clients are dropping off and the APs are joining up and all that good stuff. You can have more interfaces on your box for things like redundancy ports or an out-of-band management port. Those can all be on a shared NIC on the ESXi server. It's just the sort of the distribution port for clients and APs that sort of need to be their own standalone port there. And I would recommend a pair of these controllers so that you can do, you have more flexibility in terms of your design. I mean, they're free anyway. The only thing you gotta spend is a little extra money on an extra NIC port. If you want to get into AirOS, the cheapest option we have on that would be a 3504 series controller. The only other AirOS controllers that support SD-Access are going to be the bigger, more expensive boxes there. And the nice thing with these, you don't have to buy licenses on the 3504. You can just do the right to use licenses for free. And again, we're talking lab here. We're not talking production. And for access points, your cheapest option is probably going to be a 3702. I mean, I think you can use 2700s or 1700s, but 3700s are pretty plentiful used on eBay. They're really easy to find and they don't cost very much money. And if you want to do fabric in a box, I kind of mentioned it in the last slide, but the 9300 switch is your cheapest option for that. So fabric in a box, where you have the embedded wireless controller on a switch, 9300 is the way to go there. One is probably fine. You don't need to have every control plane node be a 9300. So what's this all going to cost? Well, individually, you can get a use ESXi server that should have the specs to run DNA Center somewhere between $3,000 to $3,500. And again, it's going to depend on where you are in the world. These are kind of US-based prices. And then if you want to buy a permanent license for ESXi, there's, I think it's the Business Essentials license, or Essentials, $600. And that actually gives you licenses for up to 3 ESXi servers with 2 physical CPUs per server. That's your cheapest option on that one. If you're looking at a 9300 switch, you can get that. Sometimes you can get a deal for around $2,000. They're very easy to find for $2,900. 3850 switches, you can find deals for $750. Very easy to find at the $900 price range. 3650 is $400 for the deals, $550 for general price. 3504 controllers, $1,200 for the deal, $1,600 for the regular price. 2911 router, $50, super cheap there. And then 3702 APs, anywhere between $40-$50. So that's kind of what the individual items are going to cost. Again, US based at the time of this recording. Things are always changing. So what would that give us in terms of actually building out a lab? So if we're looking at just wired SD access, let's say that we're not going ridiculous with anything. We're just going to get one ESXi server, a pair of 3850 switches for control plane border nodes, a pair of 3650 switches for our edge nodes, and a Fusion router 2911. You're looking at around $6,500 plus tax. And so I just basically took these price ranges and just went right in the middle of them. So if you got the good deal prices on everything, it'll be a little bit less. If you had to pay the generally available prices, it's going to be a little bit more, but ballpark numbers here. Now, if you want to throw wireless or add wireless on top of that, what I ended up doing was I swapped out one of the 3850s for a 9300, so you could do fabric in a box. We still have the two 3650 switches at the access layer. I added in an AirOS controller, so one 3504 controller, and then 3 different APs, and that brought it up to $9,660, again, plus tax. So you can see that whether you're doing wired only for $6,500 or wireless for closer to 10 grand, it's not a cheap endeavor by any means, but when you compare this to the cost of buying one physical DNA center server, we're saving so much money right there that throwing in this extra hardware, we're still easily ahead. So these are the kind of numbers you can expect. So whether it's going to be, again, for more of a home lab or even something like a work lab that you're interested in, now at least you know some ideas in terms of what you're going to need and some ballparks on the cost there. So hopefully that was helpful to you. Subscribe if you haven't done that so that you can see when we have new videos coming out, and hope to see you on the next video.